So my name's Sharisse. I'll talk to you a little bit, as Mark said, about the difference between the SAT math versus the math you're going to see in high school, and also how our classes reflect some of those differences. So the math on the SAT is designed to analyze your ability to engage in analytical reasoning, problem-solving skills, not just rote calculations that you might have as a lot of your homework problems in your high school math classes. To that end, a lot of the questions on the test are not about asking you just to fulfill a calculation, but rather to think logically through a problem in ways you might not be used to in a lot of your classes. So I'm going to show you one example of a question that is really more logic-based as opposed to calculation-based. And these kinds of questions are meant to test the adaptability, your critical thinking skills, and so on. So I'm just going to show you this one problem here. So here we have a shortened version of a previous SAT problem, and it says if a to the b equals 1, and if a does not equal 1, what is a times b? So this requires a little bit of thinking. If you have a to the b equals 1, there are only two possible ways that could happen. The first way is that we have the base, which is a in this case, equals 1, because 1 to the anything equals 1. But they tell us that a is not 1, so it can't be that. The other way is that the exponent would be 0, because anything with the exception of 0, anything to the 0 is 1. So it has to be that. It has to be that b equals 0. So that's the logic part of this. You have to think, what are the possibilities? Only one of these is actually an option in this case, and it has to be the latter, b is 0. And since b is 0 and anything multiplied by b is 0, then it doesn't even matter what a is. A times b is 0 automatically. So that's the kind of question we're talking about when we say that logic is often more important, or at least as important as having, formulas memorized and so on. So we talk a lot about that and how to approach logic-based questions in our class. The SAT is also sort of known for, maybe infamous for, focusing on some real world problems, again, as opposed to rote calculation. They're really interested in how you can apply the knowledge that you've learned to potentially real world situations. So for instance, they might ask about a hypothetical person, Gina, give you measurements of the room she's trying to paint and ask you how many paint cans she needs to buy, right? Something that's kind of set in the real world. They might give you certain parameters and ask about how long it would take a person, say Timmy, to walk to school, given that the path follows maybe certain geometrical shapes, and you have to calculate the length of those geometrical shapes like perimeters and so on. So there's a lot of those kinds of problems on the test, and oftentimes it can be distracting focusing on the situation as opposed to the math, but we teach you how to look through those kinds of word problems to approach the math. Now, I do see a question. Should we answer that now? So the question is, do we need trigonometry on the SAT? Sort of. You need like what I would call baby trigonometry. So you need to know sine, cosine, and tangent, the basics of it. You do not need to know secant, cosecant, or cotangent. There are a couple trig identities that do pop up occasionally. A squared plus b squared, or sorry, sine squared plus cosine squared equals 1. That's one of them. The law of cosines comes up occasionally, although they give it to you. You just have to know how to plug things into it. And then the rule where the sine of theta equals cosine of 90 minus theta, and the inverse also comes up. Once in a great while, there's a question that requires a little bit of knowledge of the unit circle, but it's rare. Yeah. Now, if you're taking the ACT, you do need to know more trig, but we'll talk about that perhaps another time, or if you have questions at the end. So another thing that you're going to be presented with on the SAT are complicated looking formulas and equations that are supposed to represent something you're not that familiar with. So it could be representing interest and profit, or it could represent, trying to measure the number of kilojoules something requires, or something that you're not that familiar with. In those kinds of cases, the apparent difficulty or complexity of the question is itself part of the test. They want to know, can you overcome initial reticence and maybe lack of familiarity with some of the words in the problem or situational elements of the problem and get to the core of it, which is the calculations or plugging things into the equations that they give you. So we also work on that in our classes. Sometimes that's one kind of problem that we call a leap of faith problem, where you might not know exactly how it's going to work out or even what all the words in the problem mean, but you can still address the material just fine if you take things one step at a time. Another big difference between most of the work that you do in your classes in school and the SAT is the timed element of it. So for homework problems, you generally have the amount of time you choose to spend on it. Of course, tests can be different, but even on tests in high school, you tend to have more time per problem than you do on the SAT. So time management becomes a huge element of doing well on the test. And to that end, we address time-saving approaches in our classes. We talk about things sometimes that are like little shortcuts, so you don't have to do every single bit of the calculation to get the correct answer. So just as a small example, if there's a problem that's asking how many days it takes a company to produce 200 units of whatever they produce, and you end up with a formula for day 7, which is 3 times 123 minus 3. You don't need to actually do 3 times 123. Why? You know that's going to be bigger than 200. Right? So little things like that might only save you maybe 2 or 3 or 4 seconds on a problem. But if you add that up over the course of the entire test, that's several extra, maybe minutes worth of problems that you can do per test. And so those time-saving devices are really useful. So one thing the SAT is also a little bit infamous for is asking questions in ways that might not be the most straightforward or might not be the way that you expect them to ask a question. So for example, a very simple example, oftentimes they'll give you some kind of equation or system of equations, and they'll ask you not to solve for x, but to solve for 6x or x squared. And if you're reading very quickly and not paying enough attention, you're going to solve for x. You're going to bet that whatever plain old x was is going to be one of the answer choices they give you to catch anyone who wasn't being careful. So you have to be very careful when reading the questions. And that little example, there are tons more I could give you. They might ask you, instead of for the 2 possible solutions to a system or to an equation or to an absolute value problem, they might ask you for the sum of the 2 solutions or something like that. So you just have to be wary of those kinds of things. And so one thing I really emphasize in classes is that careful reading is just as important as mathematical skill. You could be the best mathematician in the world, and if you didn't read the question correctly, you're still going to get it wrong. So just like any high school teacher, I certainly had some teachers who had favorite types of questions they liked to ask or things they were looking for in your answers, and you knew to play up to that. The SAT also has a sort of psychology behind it, and it's our job as SAT tutors to know what that psychology is and to help you address the types of things that they're looking for. So one kind of thing there is that the SAT tends to have pet topics, favorite topics that they like to cover, and they have favorite question types that they like to ask. This is not always consistent. So for instance, I've been tutoring SATs. How long has this been? 16 years approximately, let's say. And I've seen several changes over the course of that time. So for instance, in the past few years, they've become much more interested in problems involving systems of equations. There are so many more of those than there ever used to be. Likewise, there are fewer geometry problems than there used to be. And so part of what we're doing is, as SAT tutors, is staying apprised of all those changes so that we can pass that on to you and make sure that you know what to expect on the test. And that might not be the same thing that an older sibling saw on the test because things might have changed since then. Some other things, like they have favorite phrases, for instance, like they have a phrase on a lot of math questions that might be something like solve for A in terms of B and C, which is a phrase that a lot of people might be unfamiliar with from their classes. And we try to explain what those things mean so that when you get to your test, you know what to expect. And hopefully pretty much everything you see, you've already seen a dozen times by working with us, and it's old news. If you get to the point where you're bored, it's fantastic. So the SAT is also different from your regular classes insofar as it's both very broad and very narrow. So it's very broad in the sense that the SAT is going to cover material that you've seen over several years of school. This could go back to middle school. This could go back to 5th grade sometimes. So there are some things that you might have been excellent at in 5th or 6th grade, and you have completely forgotten by the time you're going to take the SAT. So for instance, finding remainders. Most people these days, you know, when you're in high school, you find, if I say what's 20 divided by 6, you're not going to say 3 remainder 2. You're going to give me a decimal or a fraction, right? You're going to say 3 1/3 or something like that. So there are some things like that that we try to remind you of and help you remember, although you may have already learned them. It might have been a while. The test is also very narrow insofar as the topics they cover tend to be quite predictable. Yes, once in a while there's a curveball. Most of the time we know what they're planning on covering. We know how much geometry, how much algebra. We know which topics within those subjects they're going to be covering. We know how much trig, just like the question from before. So our goal is to make you very familiar with those elements, not to cover everything in the world, but to focus narrowly on just those things which you need to know for this test. So one little example of that is the SAT requires you, if you're going to address every question, requires you to know the equation of a circle, but they don't require you to know the equation of an ellipse, which you might have learned in the same unit in school as the equation of a circle, right? Why one and not the other? I don't know. That's not my job. But my job is to tell you that that's the case, right? That they want the circle equation, they don't want the ellipse equation. So lastly, the SAT also works under certain assumptions that are often not what we might call common sense assumptions. So one thing that I notice in particular, just as an example, is that the SAT generally assumes that square roots are positive, except in certain cases, quadratic formula and complex number questions, which are special kind of topics. But if you don't know that, you might think there are legitimately 2 answers to a particular question, and really the SAT is expecting that you're assuming the square root is positive as opposed to possibly negative, and there's only 1 correct answer instead of 2. So all of those things are things that we teach you in our classes, and are good reasons why a class like this is really useful, as opposed to just reviewing everything you've learned in your math classes in school.